Let's look at conjunctions and intersections. We'll start with x is greater than 5 and x is less than or equal to 12. Looking at the graph for x is greater than 5, we will need an open circle on 5 and an arrow pointing toward the right where the numbers are greater than 5. X is less than or equal to 12 requires a closed circle on 12 with an arrow pointing to the left where the numbers are less than 12. This will give us x is greater than 5 and less than or equal to 12. We now look at their intersections and we can see where these two inequalities intersect. On our next slide, we can see where x is greater than 5 and x is less than or equal to 12 can also be written as x is between 5 and 12. Another example, let's graph the conjunction x is greater than or equal to -7 and x is less than 1. Again, we need a closed circle on -7, an open circle on 1, and we would color in between the two. And this can also be written as x is between -7 and 1. On our next slide, we're going to look at x is less than -3 or x is greater than 6. This is a disjunction and requires union of two inequalities. X is less than -3's graph, as you can see, has an open circle at -3 with the arrow pointing toward the left. X is greater than 6 has an open circle at 6 with the arrow pointing to the right. As you can see, these two number lines have no intersection. This is going to require a union. And it's going to be the union of the numbers where x is less than -3 or greater than 6. Finally, we are going to solve and graph an inequality, a disjunction. Let's start with -3x is less than, -3x minus 4 is greater than 8, or x minus 6 is greater than 1. First, we will need to add 4 to both sides to solve the first inequality. Adding 4 gives us a -3x greater than 12. The next step, we divide a -3. Oops, we said we're dividing by a negative. You know what that means. We